So over break, I was playing around with this type of neural network, the deep convolutional generative adversarial network. And TensorFlow right here has a pretty good tutorial for it. Uh, their tutorial is for kind of small frames and you're kind of just learning how to do numbers. And I wanted to try something a bit more complicated. So my sister is a New Yorker magazine published author, and she's got a bunch of kind of sample artwork on her Instagram. And so I downloaded a bunch of it, and I fed it to the DC neural net to see if it could learn how to duplicate it. And it really didn't, and you'll see the results later on. But it did kind of get some of the general idea, like it got the text and kind of like the cadence of the text, having kind of like lines, and then she does a lot of uh, watercolor, and so it kind of got the blotchiness of the watercolor too, and you'll see that later. These um, these lines of code, I kind of grouped them into functions. I mean, they're kind of already functions, but some of the stuff wasn't functions, and I kind of crammed it into functions. And so I'll just kind of go through and explain it from my point of view, and hopefully next time I pick this up, it'll make more sense to me. So yeah, there's the imports, like regular Python code, and some introductory stuff. And then they have their generator, and I have my generator. Now my images, as you'll see in a bit, are a bit larger than theirs. They're basically using a 28 by 21 by 28 by 28 by 1 grayscale, and I kind of wanted to add color to this, so I did a 216 and larger, more detailed images. So I did 216 by 216 by 3. The reason being is that I needed something that I could double, because I'm not fully sure about how to pick out the right strides, and so I just kind of left something that's a stride length of 2, so that it just kind of doubles or really halves. And yeah, similarly, they have their discriminator model, 28 by 28 by 1, and I have a 216 by 216 by 3. And then they have the regular functions, discriminator loss and generator loss, and the training steps, and the actual training. I didn't really change any of that. And the display image. And then they have their main function, which I'm not using because I made my own main function. And so yeah, so I've got the repository where all of the images are held. And then I kind of go through and just grab the images, and I only look for kind of squarish images, which she had a lot of in her artwork, so I didn't really filter out much, maybe like a fourth or something got removed. And then I shrink them down, so basically this is saying grab every fourth pixel, so that, and then I only grab the first 216 by 216, so like the upper, 5/6 of each square, just to even it out and make it easier for the neural network. And then, so now I've got a bunch of leaves inside of this container. I forgot the word is. And I need it to be more like a tensor loaf. And so this function right here basically tells it, hey, I actually want a bunch of loaves back to back to back to back. And I also need the images to be normalized between -1 and 1. And yeah, then I've got the buffer size and the batch size, and then just generic TensorFlow stuff like, hey, I'm going to be needing a generator and a discriminator, and here's how you initialize those. And you've got some more input parameters, like what kind of cross entropy do you want, and then what kind of generator optimizer. I was using Atom, and the discriminator optimizer, and then how many epochs. And I had 5,000 just to be completely sure that wasn't going to get any more trained, and it ended up being, I think I probably didn't need more than 500, but just to be sure. And yeah, so then it trains for a while. In that last function, sorry to go back, there was one more thing I did change, which is this function right here, generate and save images. For some reason on Python, on Linux, it kept pausing at every image with the default one, and I didn't want to have to, sit here for 7 weeks or 7 days in a row, pressing OK after every epic. And so I changed the code around so it just kind of saves the image and doesn't pause or freeze if you try to look at the images and things like that. So yeah. And then it just kind of finishes and it saves the checkpoints. And then I made one more function, which kind of makes things easier. Oh, and I made another change. Sorry, keep going back. I also make it so that it loads the data set from the last function. It's somewhere around here. I don't remember where I put it. But, oh yeah, here it is. It starts from so in other words, if it crashes or whatever, or I stop it, it'll just pick up from the last checkpoint. So that I don't have to worry about any of that. And then I have just like a simple generator function also here so that it'll just grab the latest checkpoint and then it'll just make an image out of it so that you don't have to like run everything or do any training. It's just, yeah, basically the testing or the generating function. So this is what it gave me. It looks kind of messy, but you can see that it's like trying to make letters, which, and it's trying to space them out, so it's got kind of like the cadence of my sister's comics. And then the other thing you can see in here is kind of the blotchiness of the ink, or not the ink, the watercolored paintings. And so you can see that it's kind of like blotchy. I don't know why it came out black and white. Maybe it's just the output method. I'm gonna have to look into that. But yeah, I think the biggest issue is that the art is kind of too random. I think it needs something, typically this is done with people's faces and every face is like exactly the same and all the eyes are in the exact same place for the training data. And so I think if I maybe homogenize the input data, I would get better output data. So I think that's one thing I'm going to try. And then the other thing is maybe I'll try a bigger neural network and maybe less time steps to train it. And we'll see.